Welcome to the demo video of the JIP project provided by Linkthings and the TU Delft. In this video we're going to showcase the prototype, and it is a prerequisite that the report has been read until chapter number 5. Before we can showcase the prototype, it is important to understand which entities are present in the proof of concept. We have 4 entities: Linkthings, the exporter, the importer, and the issuing bank. The exporter, importing, and issuing bank will conduct transactions, and Linkthings will be the facilitator of the network. Now, with all the stakeholders being discussed, we can slowly showcase the proof of concept. On the top half of the screen, we can see the actual user interface. On the bottom half of the screen and on the right-hand side, we can see the output of the server. It is important to note that when the user requests or performs actions in the user interface, all these actions are forwarded to the server, which in turn communicates with the blockchain network. On the bottom in the right section, we can see the server being implemented, but we will not showcase this screen when walking through the demo, because it does not have any added value. There are just some complicated, ill-defined numbers running across the screen. Again, if we look at the left-hand section of the bottom half of the screen, we can see the actual blockchain network. This blockchain network is queried by the server, and we can see how the flow of information propagates through the network. This screen is also not shown when demoing the proof of concept, but it is worth noting how the flow of information moves through the blockchain network. Therefore, I want to shortly discuss the flow of information. The flow of information propagates through the blockchain network in a bit convoluted manner. Because the propagation of the information is quite complicated, we are displaying a simplified version of the use case. So in this simplified version of the use case, there are only 2 entities in the network and only 1 ordering service. So P1 is one entity, P2 is another entity, and the ordering service depicted with an O is also present on the screen. So let's start. How does one query the blockchain? Before a user can interact with the blockchain network, he first has to physically interact with an application. So the user needs to go to A1 and requests a query. This request is sent to all the peers in the network or in the channel that need to see it. And if the application has the right the right authority, peer 1 and peer 2 agree that this request is valid and send it back to the application. Once the response is sent back to the application collects all these responses and envelops them in a single package. This package is in turn sent to the ordering service. The ordering service the ordering service only orders this transaction into a block. Because there's only 1 transaction, it is easy, so the transaction gets ordered into the block. This block is then in turn forwarded to the peers of the channel. The block now needs to be validated by both peers. They check if there are enough signatures, if enough signatures have been collected, and if the correct signatures have been collected. If this is the case, they both validate it and sign it off or append it to the ledger. It is important to note that the ordering service and the validation mechanism are mathematically deterministic. therefore making sure that the state on the ledger, although it is distributed, is always the same on both peers. Okay, now all the inner mechanics of the proof of concept have been discussed. So the user interface talks to the server, which in turn requests data or queries data from the blockchain network. We can finally start showcasing the user interface. So the other screens are not important anymore, and let's focus solely on the user interface. Before we start, let's go through the flow of the data that needs to be uploaded to the blockchain. Step 1 is a buyer is going to initiate a deal. Step 2, the seller is going to approve the deal if he feels that the deal is reasonable. And step 3, the bank, if predetermined conditions are met, turns the deal into an LOC. Now let's see how it works in the prototype. We can see that the buyer is going to log in, and when the buyer logs in, he sees a screen with data. Before he can see the screen, he first needs to query all the data, and here we can see all the data that is currently already stored on the blockchain. Of course, the buyer wants to issue a new request or a new deal, so he will go to the section Submit Request and enter all the deal details that he needs to enter. So now we can see he will issue the request and move back to the table. And when we query the database again, we can see that indeed a new deal has been initiated, and we can see this by the status of the deal status, which is issued. Moving through, now we go log into the seller's dashboard. When we log into the seller and we will query the database, we can see that the exact same data is present, but there is one addition. The seller has the buttons approve and approve available on the dashboard. And to note, this was not present in the buyer's dashboard. When we move to the Submit Request tab, we can see that the seller is not allowed to submit requests, which is logical. And when we query the data again, we're going to approve a deal. So the seller will click on Approve Deal. And when we query the database again, resulting in a new load, we can see that the status is changed from issued to approved. It is important to note that only the seller can approve deals. Moving through in the last step, we're going to the bank. The bank will log in and of course see the same screen with some different buttons. When we will, if he tries to submit a request, we can see it's not allowed to submit a request. And when we query the data, we can see that no actual buttons are displayed. As explained earlier, the bank automatically turns in approved deals into LOCs, and the bank does not need any buttons to do so. So in the back end now, the server is running and it's checking if some deals satisfy the predetermined conditions. So now we will wait a bit, and we will refresh using the query data. Oh, and there we can see one of the deals is turned into an LOC. Query the data just refreshes the data. It does not turn anything into an LOC. Oh, and there we can see it again. Some deal details have been met, and so another deal is turned into an LOC. The third deal, as we can see, does not satisfy the conditions, and therefore when we refresh the data by using the query the data button, it does not turn into an LOC. It is important to note that the query the data button only queries the data. It does not turn an actual deal into an LOC. This is done in the backend by a server. So here we can see the proof of concept has been successfully demoed, but there are, however, some small caveats we want to discuss. because this is a proof of concept. This proof of concept cannot be implemented in a real world scenario because a lot of development needs to put into the proof of concept before it can actually function like the traditional trade finance mechanisms. However, it is possible to do so, but a lot of development needs to be done by all the entities within the network. Also, we want to note that the user interface that has been showcased is merely a simple tool to visualize the blockchain network and is not blockchain security compliant. As we saw, the login is just with the simple username and password, but in a perfect world or in a perfect software package, you should log in with the certificate you also use to log into the blockchain network. And last but not least, all the applications, all the dashboards that have been shown are different instances of the same dashboard.
In conclusion, we can state that we have reached the two goals set at the beginning of the project. We have recorded all transactions of the use case on the blockchain with a timestamp and a unique cryptographic signature. Next to this, we were able to create a smart contract capable of capturing the commercial terms of the agreement between the parties. Thereby, in consultation with Linkthings, we even went the extra mile and created 4 generations of this user interface, such that even people without knowledge in blockchain can understand what's happening. Thank you so much for listening, and we're looking forward to the presentation.